Now that is where, most of the organization fail. As long as you go on a smooth, routine work, you can manage, there's no problem, you are happy. That doesn't mean that, they are making, the maximum out of it. But when there is a change, you are in trouble because you don't have much tools to accommodate or analyze these situations. So what is required is that we have to update the default solutions from time to time because of the changes. And one aspect or one tool that we can use is these operation research tools, which, relatively new. That doesn't mean that, it's very, very new. But when you consider the other subject areas, operation research is something relatively new. Now, when you look at, what are the widely used tools for day-to-day operations and activities, number one is statistical analysis because everybody is familiar, and then the simulation, and then, these things goes down in the list. Linear programming, dynamic programming, game theory, decision theory, and so forth. But, not much. But statistical analysis, everybody use because all are very familiar. So we are happy to do with, means and the variance. And then very quickly go through the history of, the operation research. It started in Industrial Revolution because when the world changed, fast, you have to use the resources, and people realize the resources are limited, so you have to do something about it. And then a lot of segmentation in the management responsibilities. So since the resources are limited and problems are complex in nature, the scientists looked into, engineers and scientists looked into, finding solutions to these problems, how to effectively use. And then during the World War, because of the urgent need to allocate scarce resources, various military activities, these researchers focused their attention on, the war, and became successful in number of situations. And because of that, this new area was named as operation research because the research done for operations in the military. And then after the World War, again, it went back to industries to plan and design the systems, and another terminology is used, which is called the systems engineering. So these are the things that, it's basically same tools, but, depending on where you apply, it, sometimes called operation research, sometimes you call systems engineering. Doesn't matter. So what my message is that, we must try and use these tools in, identifying or as solutions to our problems. Now, then we have another question, what is a problem? Right? Now, in operation research or systems engineering, we define a problem as a situation where you have some objective to achieve, and there are a number of alternative ways to achieving it, and the best solution is not clear. Then only you have to go into, applying these tools. So in the process of design, what we do is we identify the design criteria and then come up with different alternatives, and then test the feasibility, and we have to pick one solution and implement it. So what is happening in OR or in systems methods is that we try to formulate these problems mathematically using, certain tools. So what we do is we come up with the decision variables, objective function, and identify the constraints, and then use an appropriate tool to solve. Now in this process, the solving part can be done by the mathematicians, but the formulation part has to be done by the people who are involved in this particular operation, because they are the people who know exactly what is happening. Now this is the gap. The mathematics people know how to solve, but those who are operating are not in a position to give the problem for the solution. That is the gap that we have to fill. I'll give you very quickly one or two applications because of the time limitations. For example, linear programming. We can use linear programming for a simple case of starting a new transport service. Let's say we have two types of vehicles. Their fuel efficiency is different. Their capacities are different. But you have a contractual agreement to transport certain amount of material, and you have limited number of drivers. So there are constraints and the variables. So what you can do is, we can consider this as a problem with, all straight lines, equations, and formulate, the whole story we can write in mathematics, and then just with, very simple graph theory, we can solve this. And similarly, the transportation problem, everybody knows how to solve, but, formulation problem is the important part, where you have number of destinations, number of origin, you know the cost, so you have to find out how well you can, assign these from origins to destinations. But the complications arises that, some destinations are not accessible. Sometimes you have to give a fixed shipment. Sometimes you have to maintain, even if it's expensive, you have to provide that, and so forth. So there we have to use, some tools or some improvements to these standard problems. And then another application is dynamic programming, where we can use, especially for resource allocation. Here what we do is, we break the multi-stage decision problem, where we have to take number of decisions sequentially to, number of problems where we take one decision at a time. Very simple argument, and then the principle put forward by Bellman, what he says is, no matter what has happened in the past, from this point onwards to the end, we have optimum strategy to, optimum strategy, so that, you don't have to worry that, if you have made mistakes, because from here onwards you can correct yourself. So, let's say we have a situation where you have 50 million to distribute among, 3 locations, so that, you get the maximum benefit out of it. And you ask for proposals. The different groups can give different proposals. So you have to evaluate and, give, distribute this money in an effective manner. So in a simple problem like this, we can find the solution, by trial and error, but, use dynamic programming, you are guaranteed to come up with a solution. Now in this problem, very interesting, even though there are only, 2, 3, 4 alternatives given, there are 3 solutions that give the same answer. So you can allocate 1, 3 and 1 million, or 1, 2, 2, or 0, 4 and 1, all give 17 million or 170 million benefits. And also if you look at carefully, you can identify that by spending 4 million you can achieve, spending 40 million you can achieve 160 million. So likewise, you can go into the inside of the problems and understand what is happening, and then, apply that and take decisions quickly with the help of these tools. So the message is that, we should not wait just because, we are not exposed to this. We have to get into these areas, explore the new areas, understand, and then, make use of these tools to make decisions quickly, and so that, we can, develop, faster. Thank you very much.